Hi everyone! Alright, so today I want to talk about the remainder theorem. Now the remainder theorem I've written right here, what I've got. The remainder theorem says that if you have a polynomial f of x, right, and you have a binomial means that polynomial, we said it was multiple monomials. Now a binomial, it has the word bi in it, so it only means it has two monomials. So you have the monomial x and you have the monomial c. So if you have a binomial in the form of x minus c, all right, and you take your polynomial being those multiple monomials, we have, if you do that polynomial, the f of x, and you divide it by x minus c, the binomial that you have over here, whatever remains, so you have a remainder, right? In regular division, I'll have a remainder if I do 15 divided by 4, right? So if I have a remainder here, remainder is equal to f of c. So look here, but you already have c inside of here. So basically, if you plugged in c into the polynomial, then you will find the remainder of your polynomial when divided by this binomial x minus c. All right, so here I have down here an example. All right, so I have f of x is equal to 12x to the power 4 minus 33x to the power 3 minus 10x squared minus 4x plus 17. All right, and all that jazz. Okay, so if I have, this is my polynomial down here. Here's my polynomial. All right, it's got those multiple binomials, and this is the binomial that they give me over here, the x minus 3. So if I want to figure out, well, since I want to figure out actually the remainder, it is going to be, so I want to figure out the remainder of this big polynomial that has a degree of 4 divided by this binomial x minus 3. Now, f of 3 is going to be the remainder from this division. So you either have two options, all right, to solve this. All right, you have two options that you can use. All right, the first one is direct substitution. You can just, do f of 3 to figure it out. And then you also have the option to do synthetic division. All right, and synthetic division was something that we talked about from our previous lessons. So if you need to brush up on it, now is the time to brush up on synthetic division. All right, so again, remainder theorem, polynomial divided by binomial. Whatever remains, the remainder is f of the c value from your binomial. I'm not going to say that whole thing. It's really long. All right, I have this whole polynomial right here. Okay, I told you have two options working with the remainder to find the remainder. All right, of this polynomial divided by this binomial x minus 3. So we have direct substitution. Direct substitution means that you do this. So I'm going to call this the method 1. All right, and I'll box that. Direct substitution meaning, wherever you see x, that you're going to plug in our friend 3 over here. Okay, so it's going to be 12 times 3 to the power 4 minus 33 times 3 to the power 3 minus 10 times 3 to the power 2 minus 4 times 3 plus 17. You'd plug that all in. If you have a calculator, that's great. That's amazing. All right, so go ahead, plug it in, test it, see what you get. You should get -4. All right, so your answer, the remainder that you would get if you divided our huge polynomial by this binomial, you would get -4. This would be the remainder of that polynomial division. Okay, and this is basically the remainder theorem at work. Now you have method 2, which I've written up there. Method 2, you can use synthetic division. All right, so synthetic division says you have the x minus 3, which is what we have. All right, so I would put a 3 out here, and inside my synthetic division is long because we have a long polynomial. All right, and go in order of the degree. So it's 12, -33, -10, -4, and 17. Okay, so synthetic substitution. All right, I'm going to move this up a little bit just so you could see everything. Okay, yeah, I think it's more visible. All right, so I'll go ahead. The first one, we don't touch it, bring that down. 12 stays the same. 3 times 12, we get 36. 36 plus, or -33 plus 36, you would get 3. Then you would do 3 times 3, 9. And then add that, -10 plus 9, you get -1. Then it's 3 times -1, which is -3. Add those two together, -4 plus -3, -7. Then you have 3 times -7, which is -21. Bring it to the next value. Add those together, 17 plus -21, you would get -4. Right? This last value right here, this is your remainder in synthetic substitution. So this last value, if it's a 0, then that means you have no remainder, right? But this last value, again, I'll say it again, this last value over here is incredibly crucial in synthetic division. This means that you have a remainder remaining from your division of the polynomial and binomial. Factor theorem. All right. Before I jump into that, do you remember the remainder theorem? All right. So what did the remainder theorem actually say? The remainder theorem said that if you have a polynomial and you divided it by a binomial, so again, a binomial was two monomials basically together, only two monomials. Polynomial was multiple monomials, but they were specific monomials. All right, and we said that whatever if I wanted to find, if I divided the polynomial by a binomial, we said that their remainder is equal to f of c. All right, now remember the binomial had the form x minus c, and the polynomial, we called that f of x. All right, so basically if you took this c value right here and you plugged it into f of x, then you get your remainder. All right, it was either direct substitution or synthetic division. All right, that's how we could find our remainder. Now, let's see what we can do. Now, the factor theorem says, well, what if your remainder, your f of c, is equal to 0? All right, so what if it's equal to 0? Then x minus c is a factor of the polynomial. Of the polynomial f of x. All right, so again, what does it mean by factor? So whenever you do, let's take simple numbers right now. If I did 54 divided by 6, what do I get? I get 9. It's a number without a remainder. The remainder is 0. 6 of those 9s will go into 54. Okay, now let's say I have a polynomial. So now I'm working with a polynomial, multiple monomials, and I divide it by a binomial x minus c. And if the remainder is 0, which is what we have in this case, x minus c, the binomial, is a factor. It goes into the polynomial exactly that many times. I don't have a remainder anymore. So it's the same concept with the 54 divided by 6 is equal to 9. So let's work with an example on the factor theorem. All right, so yeah, basically the factor theorem is the remainder theorem at work. All right, I'm going to go ahead and erase this because we don't need this anymore. Oh, it's getting messy. Okay, we don't need the remainder theorem because this is basically the factor theorem. All right, so let's work with an example. I have, let's say I want to determine whether, so question's asking you, is x minus 5 a factor of the polynomial x cubed minus 7x squared plus 7x plus 15. So is x minus 5 a factor of this polynomial? Okay, so what do I need to do? I choose one of those methods that we talked about earlier, either direct substitution or you can do the synthetic division. But I'll do synthetic division just because we can brush up on it. All right, so synthetic division says if you have an x minus h, your h goes out here, and then you will make like the division symbol. And inside of it are each one of the coefficients of your degree. So it's going to be x cubed, that's our first one, it's a 1, the coefficient is that. The coefficient of the next degree, which is 2, is negative 7. The coefficient of the next degree, which is 1, is 7. And then my constant is 15. Alright, so let's go ahead and use synthetic division here. 1 stays the same, bring that down. 5 times 1 is 5, bring that up here. Negative 7 plus 5 is negative 2. 5 times negative 2 is negative 10. Add that. 7 plus negative 10 is negative 3. 5 times negative 3 is negative 15. And then you add the 15 to the negative 15, you'll see that that's 0. And remember, your last spot is your remainder spot. So it equals 0. So is x minus 5 a factor of x cubed minus this whole polynomial right here? I see that it's equal to 0. So yes, I can conclude that x minus 5 is a factor. Yay. Okay. All right. Thank you, girls. Thank you for watching.